Hello everybody, my name is Jacob Damrow, and today I will be teaching you about the concept of ocean acidification. The term ocean acidification refers to a trend seen in ocean water in which it becomes more acidic over time. This simple definition is based off of observed pH values. By this, I am referring to the pH scale, which can be seen here. The pH scale ranges from 0 to 14, with 0 being the most acidic and 14 being the most basic. This can be seen on the middle of this diagram, with the red parts being acidic and the blue or purple part being basic. If you look at the left-hand side of the scale, you will also be able to see that pH refers to the concentration of hydrogen ions that are contained in a substance. So the numbers on the top of the left-hand portion are bigger, while the numbers on the bottom are smaller. This indicates that acidic substances contain higher concentrations of hydrogen, while basic substances contain lower concentrations of hydrogen. Currently, the ocean has a pH of 8.1. This might appear basic at first glance. However, in recent years, the pH has been steadily decreasing as the ocean becomes more acidic. Thus, the term acidification in ocean acidification. But how might all of this occur, you might ask? Well, the main proponent of ocean acidification is the carbon cycle, which is depicted here. The carbon cycle is the journey all carbon atoms must endure as they go through their form changes. So, for example, some carbon starts off as fossil fuels, coal, oil, and gas seen in the ground. This can be seen in the bottom left portion of this diagram. Then, these carbons can be transferred to vehicles in the form of oil or factories, and then are emitted into the air by these devices. This then leads to absorption in the oceans. This is a naturally occurring process. However, since the beginning of the Industrial Revolution, there has been a lot of excess carbon which has entered the cycle. A result of this has been the ocean's absorption of high levels of CO2. According to the National Oceanic and Atmospheric Administration branch of the U.S. Department of Commerce, it is reported that by the end of the century, the surface waters of the ocean could have a pH around 7.8. When compared with our current ocean's pH of 8.1, it is clear the results of this are because of some sort of abnormality. As CO2 molecules are absorbed into the ocean, they bond with water to form carbonic acid, or H2CO3, which then breaks apart into hydrogen atoms and bicarbonate atoms, or HCO3 minus. This increase in the concentration of hydrogen atoms in the water then causes the pH to decrease as the water becomes more acidic. All of this can be seen in the diagram on screen currently. But what are the effects, you might ask? Again, ocean acidification can be devastating to aquatic communities it impacts. Fish are very sensitive to pH, and fluctuations in pH can have very serious and very harmful effects, such as degradation of the organism's shells and skeletons, and the erosion of habitats, such as coral reefs, like the one depicted here. This was once a bustling and thriving community. However, due to the changes in pH, that is no more. What is humans' role? As mentioned earlier, ocean acidification has been on the rise since the Industrial Revolution. As technology has advanced, we have been enjoying the benefits, and that has come with a price. The price is pollution in far greater amounts than we contributed before. Examples of the ways humans contribute to ocean acidification include emissions of CO2 from our cars, boats, planes, and from the factories, such as one of which is depicted on screen currently.